We gotta get going. We have so many things to do today. We planned for too many things today, but it will be okay. We will get through it somehow. We're gonna go ahead and do 9 and 10 of the math workshops. Tomorrow, our plan is to not do any math workshops at all. Why is that? Okay, so we can have a point. Because we have a quiz tomorrow. We would like to not do any math workshops. We want to focus on our quiz. It is a 15-question quiz. After we finish all the notes today, I will specifically go over, like, there are 3 of this kind of problem, 2 of this kind of problem. If you are new to me, you do not have to take the quiz tomorrow, but you would like to go ahead if you could. Again, this is mostly what we've been discussing, our review skills. The classifying numbers, not so much. So if you're new to me, we might cut out the classifying numbers for you, but like solving an equation, I think you already knew how to do it before you met me. So you probably could take it tomorrow and still be just fine if you're, I don't know, a motivated student normally. Okay, last night you had homework. First period lucked out so nicely that I talked for so long that I never even checked it. Maybe you will work out just as nicely. You hope that. That would be nice. But we'll see. Tonight's homework, it says page 12, number 1 through 15. So if you're looking at your packets, it's actually on the back. And I want to be very specific because there are 2 different worksheets. So it's 1 through 15 odd on the top one. So 1, 3, 5, 7, 9, 11, 13, 15. Okay, even though I'm assigning 1 through 15 odd, if Nick wants to do more than that, I'm not going to be mad at him if he does. He might get a little bonus out of me, in fact. It would be smart of Nick, after today, if he realizes, oh no, I've forgotten how to solve an absolute value equation, then hey, maybe he should practice those absolute value equations down at the bottom, like 16 through 20. Or after today, Nick's like, hey, I really don't know how to solve an equation for a specific variable, then he might want to practice 13, 14, and 15. So if Nick wants to do more after today's lesson, I would totally understand. However, Nick at least needs to do 1 through 15 odd on the top set. Okay, I need help. Knowing why there are loud people in the hallway. I need help with my math workshop number 9. Yes, table 3.
I got 4x squared minus 3x plus 5.
I believe he's correct, but again, you know Miss Compton has troubles with negatives, so I've got to distribute that negative. I would have had 3x squared minus 7x plus 5 minus the negative is plus x squared minus positive minus 4x 3x squared 1x squared, that is 4x squared. However, negative 7 and negative 4, I get negative 11. So it should be 4x squared minus 11x plus 5. If you were like me and you made a mistake, then you need to distribute the negative. Because you and negatives, you struggle, like me and negatives struggle. Did you add a point for answering table 3? You can have a point for answering. Okay, and then number 10. Yes, ma'am.
3c squared plus...
3c squared.
I did 3c squared plus negative 2c plus 5.
I'm going to put minus 2c, but yes.
Yeah.
Instead of the plus and negative, just because
Can I do that or not?
Yeah, you can. This just makes it easier. Less stuff to read. So 2 plus 1 is 3. 7 minus 9, you get negative 2. 4 plus 1 is 5. Perfect. Are there any questions on 9 or 10 of our math workshop? Okay, then we're going to go ahead and get to our notes. Maybe by some miracle I'll talk faster in here, or maybe y'all are geniuses, and we'll get to do the notes, the ACT prep, and everything we'd love to do. There's also supposed to be a checkpoint today. Somehow we've got to make all the things happen. Okay, yesterday we were discussing how to go from verbal to an algebraic expression. And we talked about, I think most of us had down going from the actual written to an algebraic expression. The harder is actually from the algebraic expression to verbal, just because there are so many words we can use. I am not going to count off. If Ellie says what we call the non-fancy sentences. If Ellie says a number squared minus 9 equal to 72, if she writes it exactly like she sees it, a number squared minus 9 is equal to 72, I'm not going to be mad at her. She does not have to be fancy like me yesterday when I was having my fancy sentences of 9 less than a number squared. Am I impressed if you fancy sentence it? Of course, but you don't have to. I get that minus and less than mean the same thing. I get that. I was trying to be fancy with my English. You don't have to be fancy with your English. This is math class. Okay, were there any questions from the homework, though? Even though I'm not checking it right this moment, were there any questions from it? I assume that goofy smile means it didn't happen, so you really don't want me to check it anyway. Okay. Today we're actually going to do less verbal and more algebra. We're going to solve some equations. So there's some steps at the top that you might want to read that are useful. I believe you know these, but they're at the top to remind you anyway. There are some problems today we're going to skip just for the sake of time. Okay, so on number 1, what's the first thing I do to solve for y? Okay, I'm going to add 8 to both sides. I have negative 6y equals 24. Now what? Okay, table 2, you can get the point. I was actually looking up for that one. And you end up getting y equals table 5, you can get the point. Okay, again, Miss Compton's in a hurry because we have a lot we're trying to cram in. If Ellie's trying to get a perfect score, because she is, she likes to make an A, it would always be smart to do what when she gets your final answer? Check it. So 5, you can have the point. I knew Ellie was going to say that with the fastest. Always plug it back in and check yourself. Even if you just do it in your head. Now plug in negative 4. Negative 6 times negative 4, that's positive 24. 24 minus 8, hey, that really is 16. So it's always a good idea to check. Always a good idea. Okay, let's work number 2. What should I do on number 2? Okay, we need to combine our like term, but I need someone to just tell me specifically. What do you want me to do? Subtract. Okay, I'll subtract 5p. That sounds pretty good. Yes, you could have added 20 first. You could have subtracted 12 first. And there is no wrong way to start this one. I like to subtract 5p. I think Nick said it. I like it. Okay, and now what am I going to do? Okay, so I add 20 to both sides. Does anyone already know the final answer? I heard it from 2, 4, and 5. So they can all get a point. Did you say it as well? Then 3 can have a point. I thought there was a table I was leaving out. Okay, so I add 20 to both sides. 20 plus 12 is 32. I divide by 4. I get p equals 8. Okay, I realize this is not your first rodeo in math class. This is not your first time to solve an equation. Your own math teacher probably wanted you to show every single step you'd ever done. Now, that's not a bad thing, but I'm okay, for instance, if Nick has on his paper 32 equals 4p, 8 equals p, like he doesn't actually show me where he divided by p, I'm not going to be mad. I get that he does some math in his head. I do not mind math in your head, but if you're making a lot of mistakes, it sure would help if I could help you more if you showed me things. Just my 2 cents. Okay, so we're actually going to do 3 and 4. We're going to skip 5. That makes you excited. We're going to skip 5, but if you wanted to do it for fun, x ends up equaling negative 6. Okay, 1 and 2 seem pretty easy, but that's because they didn't have fractions or decimals, so that's why we're going to work 3 with the decimals. I need to distribute that 0.5, so I have 0.5c plus 1 and 2 can have a point, minus c equals 0.6c plus 0.3. Okay, and then what should I do from here?
You can subtract, the 0.16.
Okay, so she's not wrong, and I could start moving people around the equation. I agree with that, but Nick's realized before we do that, it might be a good idea to combine these two like terms. I mean, there are two C's on the left, two different C terms. Why don't we add them together, and we only have to worry about the one C term. So I add 0.5 and negative 1. I get negative 0.5 C plus 1.4 equals 0.6 C plus 0.3. Okay, so from here, Delaney, right? Delaney could do whatever she wanted. She could subtract 1.4, she could add 0.5. I don't know what she's going to do. I'm going to add 0.5, but she does not have to exactly solve it like me. I do not need a twin. Trust me, one of me is enough. So I have 1.4 equals 1.1 C plus 0.3. What would I do next?
Subtract 0.3.
Okay. 1 and 2 can have a point. Does anyone already know the final answer? 2 can have a point. So you end up with 1.1 equals 1.1 C. And I had someone last period who said, hey, if you have 1.1 equals 1.1, doesn't that mean it's 0? And we had to remind them that when you divide 1.1 divided by 1.1, you end up getting 1 equals C. Okay, are there any questions on 3? Then we're going to move on to 4, where we see a lot of fractions. But again, if you look at the top, for the steps to solving an equation, our first thing we like to do is to get rid of those fractions if we can. So I agree we could get a common denominator and we could move people over. And that's great. And there's nothing wrong with what we've been doing. But we're trying to be pretty fast now. Is there a faster way where we could just kill off all the fractions all at once? Is there a magic number that we can multiply everybody by? Say it again.
Was that right?
Say it again.
I said 12.
There's a magic number, you can have your point. That we can multiply everybody by. That's going to end up making everybody cancel out, or at least all the fractions are going to go away. And you're going to say, why did she choose 12? She was trying to think of a number that 2, 3, and 4 would all divide into. She wanted to go with like 6, and I heard someone else say 8. But 8, 3 doesn't go into that. So that's why she's picking 12. So if we multiply by 12, you don't have to write this line because that's where you got math skills and you can do some stuff in your head. But to prove a point, you would have 12 over 2z plus 12 over 4 equals 12 over 3z plus 60 over 4. But Cooper seems pretty smart, and he can do math in his head, so he doesn't have to write that line. He goes straight to simplifying. What should I put on my paper? 6z, and then what? Plus 3, and then what?
Equals 4z.
4z, and then what?
3.
Plus
Plus 15.
15. Perfect. Okay, I had help from 1, 2, and 3, so 1, 2, and 3 can have a point. Okay, and then again, Karen was right. You can solve this many ways. You don't have to be my twin. This is just me doing my thing. If she wanted to subtract 3 instead to begin with, she sure can. What do you end up with getting your final answer? Whoa, that was good. Everyone can have a point. So I have 2z equals 12. So I end up getting z equals 6 when you divide both sides by 2. Okay, so let's go back through that one again. We multiplied by 12 because we were trying to get rid of all those fractions. We realized that multiplying by 12 is really nice because we ended up having nice, pretty numbers. No more fractions. 6z plus 3, 4z plus 15. And then from there, it was normal math, just solving. I moved all my z's over to one side. I moved all my numbers over to the other side. I solved for z. Are there any questions on 4? Okay, well then let's apply the same kind of logic to 6. And I've written all of them 6's way, so I'm going to have to write it again. 6 is x plus 3 divided by 4 equals 5. Is there some number I can multiply both sides of the equation by to get rid of that denominator? Perfect. If I multiply it both sides by 4, I would have 20 on the right. What would I have on the left? Just x plus 3. And if you can do that in your head, duh, go for it, because you understand the 4 and the 4 cancel out and you have just x plus 3. But for those of us who haven't had our Wheaties this morning, totally understand. Let me write it out for you. And so that's why the 4's are going to end up canceling out. And that's why we end up having x plus 3 equals 20. So x equals 17. Perfect. Again, Nick is going to get as long as he needs tomorrow on this quiz. That's why we're pushing the math workshops. That's why we're going to get it all the way so Nick can spend as long as he needs on this 15-question quiz. I'm hoping Nick's going to realize I should plug stuff in and check. 17 plus 3 is 20. 20 divided by 4 is 5. Nick is right. I'm hoping that by giving Nick lots of time, he actually makes sure he is 100% right. Because I would like for Nick to get an A, but we shall see. Okay, flip over to the next side. I love you enough to not do number 7. I wrote down that answer somewhere. Where is it? I love you enough to not do number 7, but if for fun you wanted to do number 7, you would end up getting C equals negative 3. Okay, well, I do love you enough to not do number 7, because I understand you're understanding this fraction thing. You understand it, just like you can handle it. I believe you can handle it. I'm just for time's sake. Let's go on to number 8. We cannot skip it. I know it looks easy and you know what to do, but we cannot skip it. What's the first thing we should do? Okay, so you go ahead and you try to solve. Let's go for it. Can someone read me what they had after they distributed? Okay, and that's what I got too. And then what should we do from there? Okay, so let's combine those like terms. And if you're getting ahead of me, that's great. Not a problem. 7 minus 3r, negative 8 minus 3r. Okay, I've done a lot of math problems. I realized we had an issue here. If you realize you have an issue here and you already know the answer, I don't care if you already write that answer down. Does anyone already know the answer to this problem? Yeah. So if you recognize that from here, I don't care if you write those two, that what you said, I think only me and your table heard you, and you can add a point for that. But I would write it down from there. Now, you know, to prove it to the rest of us, because you don't know what she said, if we added 3r to both sides, what happens to the r's? Okay. So then what do you kind of want to put as your answer? Not you, Tylen. Anyone else but Tylen? Okay. Does 7 equal negative 8?
No.
Isn't that complete junk? So it's not possible. So what do we put in math class when things aren't possible? No solution. But Tylen, again, she recognized it 2 lines ago. So does she have to keep going? No. She can stop when she recognized it and put no solution. But she's better be pretty confident she's right, though. So we had to practice 8 because it is a no solution problem. And you're pretty smart. I can bet you would guess what we're going to have on number 9. We did a no solution. Now we're going to all of the solutions. Table 3 can have a point. We're going to have all the solutions. Every single thing is going to work. Every single thing that is a real number is going to work. Okay, so same sort of thing on number 9. So you go ahead and start working. Distribute that 5. combine those like terms? Okay, so you distributed the 5. You had 5h minus 7 equals 5h minus 10 plus 3. Hopefully you combine those two like terms, and you ended up with this line that said 5h minus 7 equals 5h minus 7. Everything I did in purple is not really necessary. Once you realize you have the same thing, like they're identical, 5h minus 7, 5h minus 7, and they match, it's automatically going to be all real numbers, automatically. But if you wanted to keep going like I did in purple and prove to yourself -7 equals -7, yeah, that's always going to be a true statement, then our answer is all real numbers, but you and I are fancy now. We just got done talking about number systems and classifying and how to write things, so we know when we say all real numbers, the letter for that was R. So we're going to put that R. Okay, are there any questions on that one? Okay, so I know you know how to solve an equation. You made it to Algebra 2 a trig. I'm pretty sure you can handle it. I'm not really worried about solving an equation as much as I am about this next section where you solve the equation for a specific variable. We call that literal equations. I know if you had me in Algebra 1, we learned it, but I don't know who you had for Algebra 1. So anyway, so what's really annoying with these is we're not actually going to reach an answer. All we're going to do is rearrange this equation. Rearrange this equation for whatever letter it says. So right now it's solved for Z. They want us to solve for H. Or for instance, right now it's solved for Y. They want us to solve it for A. Right now it's solved for F. They want us to solve for A. So all we're going to do is rearrange them. We're going to use our normal math skills to rearrange this stuff. So for instance, right now, on number 1, who's bothering the H? On number 1, who's bothering? The pi and the q to the third. So how do we get rid of pi and q to the third? We're going to have to divide. So table 3, you can have the point. So we're going to divide both sides by pi q to the third. You can. You can go higher. You can be off the chart. Trust me, one day you'll be below the chart and be happy for that off the chart day. So all I did was divide both sides by pi q to the third. And the only reason I picked pi q to the third is because they were bothering the h. And in the directions it said, hey, solve for h. So now we've solved for h and we're done. Do we really feel done? No, it just feels like we've moved some junk around. But that's all we're really doing when we solve an equation for a different variable. Okay, number 2. We got to move everybody around and solve for A. So BX and C have to move. How am I going to get rid of BX and C? I'm going to subtract them. And so I'm going to subtract BX from both sides. I don't really have enough room on the left. I'm going to subtract C from both sides. And so on that left-hand side, I'm going to have Y minus BX minus C equals AX squared. We got rid of the BX, we got rid of the C. We moved them to that left-hand side. Let me zoom in on that. We moved over the BX, we moved over the C. We subtracted by them on both sides. That way we could try to get A by itself. Are there any questions about that step? Okay. Is A by itself? No. Who's bothering A? So how are we going to get rid of that x squared? Okay, everybody can have a point. Let's all divide by x squared. Now, I'm pretty lazy, and from here, I would probably just circle this, because I'm like, that's the answer, that right there. But if you want to write it one last time, you sure can, of y minus bx minus c all over x squared equals a. And while that doesn't feel done, we've technically followed directions. We have A by itself, everybody else on the left-hand side, and we didn't break any rules of math or nature when we solved. Okay, are there any questions on 2? We're going to keep on at it. Then let's go to 3. It wants us to solve for A. That seems kind of weird. Any thoughts on how to solve for A? Okay, so I thought about distributing too, so we can distribute. And then, are we being in ABC order today or no? Nah, he said, so I'm going to do CA, but if you're an ABC order stickler, you wrote AC, which is fine. CB minus D equals F. So your paper might already look different than mine. You might have AC, BC minus D equals F. We do not have to be twins. Okay, is A by itself? Okay, so who do we need to move over? Okay, I'm going to subtract CB, and I'm going to do what? Add D. So I need to subtract CB, so it leaves the left, and I need to add D. And I end up having CA equals F minus CB plus D. Now, Nick and I are just putting things in order like we see them. If you're an alphabet stickler, you probably have negative CB plus D plus F equals CA, which is fine. Okay, is A by itself? So we've got to divide by C. Again, Miss Compton tends to be lazy. So at this step, I would probably just circle that and say, hey, that's the answer. But if you've got the extra time and energy, you can write it one last time. Okay, this is all I expect from Cooper. This is all I expect from him. I don't think that's that bad. Now, if Cooper wants to be an overachiever on this one, he can. But he does not have to be. He does not have to be. Okay, notice how there is a C in that middle term and a C in the denominator. You could split it up and have F plus D over C minus D. Because the C and the C, if we made this over this its own separate fraction, those C's would cancel out, and you would have just minus D. But this is you're being straight up extra. So if you want to be extra, that's great. I can totally understand you. Do you have to do that? No. I'm good with what we circled in purple. Okay. Are there any questions about that one? And then flip to the back or to the next page. You'd say, Miss Compton, why can't we skip 4 and 5? Well, no. We finally put numbers in these and we're solving for a specific variable. So we probably need to practice that. So on number 4, it says I'm supposed to solve for y. What's the first thing I should do? Table 3 can get the point. So if I subtract x from both sides, I have 2/5 y equals z minus x. Is y by itself? What's bothering y? How do you get rid of the 2/5?
Divide.
You could divide by 2/5, but you know a better, fancier way. By the 3 can have the point. He was all over it. Okay, if you multiply both sides by that reciprocal, and I genuinely mean both sides, so you have to multiply this half by 5 halves, and you have to multiply this side by 5 halves. It works out nicely on the left because the 2's and the 5's cancel out, so you get y by itself, and you end up having y equals 5 halves z minus x. Okay, have we solved for y? Is y by itself? Yeah, so do you have to distribute that 5 halves to the z and then the 5 halves to the x? No, you don't, because we've solved for y. You can keep going and be extra if you want to, but technically we're done because y is by itself. Are there any questions on 4? We've got one last one like this. They want us to solve for y. They just love solving for y, don't they? What's the first thing I should do? If you multiply both sides by 2, you will have x plus y equals 2b. If you subtract x from both sides, you end up getting y equals 2b minus x. Now, if you need to write it, you sure can. I subtracted x, I got y equals 2b minus x. Are there any questions on how we got y equals 2b minus x? I completely agree that we're just rearranging junk. I mean, our original problem had a 2, an x, and a y, and a b. Our final answer still has a 2, an x, a y, and a b. We're just rearranging junk, like you rearrange your room. You just push your stuff around and make your mama happy, but you don't actually get rid of anything. Okay. Now for the fun stuff. Absolute value. Do you remember how many answers you're supposed to get with a typical absolute value problem? Okay, I saw it with 3 and 5, so you can add a point. You're supposed to get 2 answer choices. So you might want to make a note to yourself. Abs, val, normally has 2 answers. Can anyone explain in English why an absolute value problem normally has 2 answers?
Isn't there like a negative version?
We're going to consider the negative and the positive versions. Why is that? What do the bars do? They make it positive. Everything is positive. So if you're like, I still don't know what that means, Ms. Compton, it's been a while. You don't have to write this. I'm just going to prove a point. So we're really not sure. We know that something plus 5 equal 9. And yeah, I totally get 4 plus 5 is 9. Absolute value of positive 9 is 9. I get that. But what we're not sure of is we're not sure if this inside stuff was actually a negative 9. So when we took the absolute value of it, it made it positive 9. So you want to say the answer is 4 because 4 plus 5 is 9. But really the answer could also be negative 14 because negative 14 plus 5, well, that's negative 9. The bars make it positive, so really it's positive 9. So that's why there's 2 answer choices, because inside the bars we're really not sure if it was a positive or negative value, because those darn bars make everybody positive.
It's the first one, 4 plus 5?
Yes, 4 plus 5 and negative 14 plus 5. Did you have to write what I wrote in purple? No. Okay, so the long story short is we're going to have 2 answer choices every time. 1, 2. Or at least that. I say that, we're going to go to number 2, it's only going to have 1, but you're going to see why. It's, of course, going to contradict myself immediately. Okay, so we're going to do d plus 5 equals that positive version. But again, we're not sure if what was inside the bars was positive, or if the bars made it positive. So we've got to have the positive version and the negative version, because those darn bars are making it positive regardless. Okay, then I already solved my own equation, sadly enough, when I was showing you my little purple stuff on the side. When you subtract 5 from both sides, you end up getting d equals 4. When you subtract 5 from both sides on the second option, you end up getting d equals negative 14. Are there any questions on number 1 with the absolute value? Okay. Number 1 was set up nicely because it was absolute value was already by itself. We're going to do number 2 because the absolute value is not by itself. Our goal is to get the absolute value by itself and then do our math. So what do I need to do in order to get 2a minus 4 with the bars by itself? Let's divide both sides by 3. If I divide both sides by 3, I have 2a minus 4 equal to 0. Okay, and then you know Ms. Compton had just said you're supposed to have 2 answer options. So you're trying to do 2a minus 4 equals to positive 0. And then you're like, okay, so then I do 2a minus 4 equals negative 0. Is there a negative 0? No. So because this was 0, if it had been 3, 5, 7, any normal number, we would have done both versions. But because it's silly 0 and 0 is only positive, we're only going to have the one answer. What is our one answer? A equals 2. 2A equals 4. So A equals 2. Okay, I'm going to break Nick's heart. We're not going to do 3 or 4. Mostly because I, like you, am trying to push through math class and avoid fractions if possible. So number 3, if you want to work it for fun, y equals negative 1/4 is one answer. Y equals negative 9/28 is your other answer. Yeah, whoa. Didn't want to do that. Number 4, one answer is nice. Y equals negative 3. However, the other answer, y equals negative 23 divided by 3. So needless to say, you and me in 3 and 4, we're going to, thanks, no thanks. But we will do number 5. We will do number 5. Okay, so let's go to number 5. What do you think the first step is on number 5? See, I would think that as well. But we got to subtract 8. So again, we want the absolute value by itself. We've got to get rid of everyone bothering that. So let's subtract 8 first. And we will have 2 absolute value 3x minus 4 equals negative 2. Now what do I do? Divide by 2. Ellie, your group has answered quite a few questions. If y'all aren't at 3 already, are you at least at 3 points? Okay, good. Just making sure. Because your group is, I'm telling you, she likes to answer things. You're going to be happy she joined you. Okay, so you end up having absolute value 3x minus 4 equals negative 1. Now what? That's great. So Nick wants to solve. Nick, for once in his life, is wrong. He's very rarely wrong, but Nick is wrong now. It's not possible because it's negative. So I'm going to write. Okay, so I'm going to write no solution because we have those absolute value bars, and we're trying to say, you know, that whatever this is going to be positive. So is this positive thing ever going to be equal to a negative number? No. So if you ever end up in this situation, it's going to be no solution. Nick was almost tricked. He almost wanted to keep working and solve. I promise I don't think I'm tricking Nick on the quiz. Just so you know, it is possible to be tricked in the future, like on the test that will eventually come up. Hello, Coach Hammer.
Hey, try it for.
Oh. Cooper, there is a blue checkpoint on my desk. You pass them out to everyone. I'm too straight. Yeah, I got one card. Yeah, I didn't know that. Okay. I could have stopped recording at some point. We already went over what your homework is. You have a checkpoint in your hand. I get that the bell doesn't ring that far away from now. Man, wouldn't it be nice to go ahead and get this checkpoint out of the way? I'm going to say that Cooper can't take the quiz until I'm confident Cooper has passed this checkpoint. Because let's face it, I don't want Cooper to blow. This is only a 20-point grade versus like a 100-point grade. I want to make sure Cooper knows what he's doing before I give him the quiz tomorrow. And now that Coach Hammer has distracted me, I almost forgot to do the most important thing of the day, which was telling you what was on the sticky quiz tomorrow. You already know what homework is. I'm not even going to check your homework. I'm just giving you points for it. We're going to pretend like you did 1 through 10 last night. You're welcome. Especially table 1 with their eyes looking darty. I'm just going to give you 10 points for last night's homework, even if you didn't do it. I'm not gonna know.
Last minute.
Tomorrow, you're not gonna be as lucky. Tomorrow, I actually am gonna look and see if you did these. I think I said it earlier. If Nick does extra, I'm willing to give Nick bonus. As for that quiz tomorrow, I know there are. It was just in my hands. Where did it go? That is not the quiz. Where are you, Beth? I know there are 5 problems on classifying a number. Real, imaginary, not imaginary, real, integer. You know how to do that. There are 2 problems on evaluating. Like given specific values, can you evaluate? There are 2 problems on simplifying expressions. Just simplifying. Yes, there are some fractions. There are 5 problems on solving an equation. And sadly, one of those solving an equation problems is an absolute value. And then last but not least, there is 1 solve for a specific given variable. 15 problem quiz. That's what we will do with tomorrow. Obviously, since you're quizzing, I will have lots of free time, so I will for real check tonight's homework tomorrow, you lucky dogs. Okay. Work on your checkpoint. If you get it finished, great, bring it to me. If not, I'm going to say it's part of your homework too.